Coming up on this week's episode of TechSNAP, Google and OpenDNS have joined forces to make your downloads faster. We'll tell you what they're doing and how it works. Plus, Gmail suffered another man-in-the-middle attack, and the kernel.org folks have a little bit of egg on their face. All that and more in this week's episode of TechSNAP. Hi everyone, and welcome back to TechSNAP. My name is Chris, and this episode was recorded on September 1st for release on September 2nd, 2011. My name is Chris, and joining me on the Skype line, like every single week, all 21 of them, is Alan. Hey there, Alan.
Hey, Chris.
Hey, welcome back to TechSNAP, buddy.
Yes.
And happy early birthday.
Yes, thank you.
Probably by the time most folks are watching this, because this comes out on Friday, your birthday's on Saturday. So happy birthday, yep. Alan. And Google wanted to give you a couple of early birthday presents. Our news lineup this week is filled with some pretty, well, one Google story is a little scary and one Google story is a little awesome. And the one I'm really looking forward to is this whole OpenDNS and Google coming together and making DNS faster. Because I saw this headline earlier this week, but to be honest, I just haven't had time to process the whole story yet. So I'm looking forward to digging into that.
Yes.
But before we get into all of that, should we maybe jump right into our first story? Because not only do we have a bunch of news, we've got a feedback, a massively packed roundup, and then we've got a good Bitcoin blaster at the end to finish things off with. So we probably ought to just get rolling here.
I think so.
All right, man. So let's cover our first story. It's sort of in the theme of one of our first stories from last week, and it's another SSL certificate authority has been compromised, and this time
and that's from the very first episode, wasn't it?
I think we've covered a couple of them. Right. But this one impacts Gmail users, doesn't it?
Yes. It's very, very similar to the previous one, actually.
Which also
targeted Gmail.
Oh, right. In fact, Google's got an update here on their blog post about this whole issue.
Yep. So basically what happened was another SSL certificate authority was compromised and issued somewhere around 200 fraudulent certificates for everything from Google, Microsoft, Yahoo, Mozilla, etc. And they caught on to the fact that they were compromised at some point and revoked all the certificates. But apparently they missed the Google one, which I don't know would have been the most important one probably.
Yeah. So go figure.
They say that on July 19th, they discovered the fact that their system had been compromised. Now, they didn't mention when the system was compromised, likely because it was an embarrassingly long period of time.
Well, that's what I'm wondering, yeah.
Because the fraudulent Google certificate that was out there had an issuance date of July 10th. So for at least 10 days, likely longer than that, their system had been compromised in issuing fake certificates.
And I guess the certificate was issued by DigiNotar. Does that sound Notar?
Yes.
Does that sound right?
Yeah.
Chat room was asking. Something like that.
It's Dutch, so I don't know how you're supposed to pronounce it.
Okay. There you go. So but there's been no exploits based on this, right? So we know of?
There have been, yes.
There have been. I hadn't seen anything about that.
Well, specifically, for this to work, it's a man-in-the-middle attack. So someone has to be between you and Google, and then they just pretend to be Google.
Oh, yeah, sure. But we don't know anybody doing that.
This attack was launched by the Iranian government to intercept the Gmail communications of people in Iran.
Oh, okay. So we do.
Right? And since they control all the internet connections there, they just route all connections to Gmail through their own server, where they have a fake certificate so they can claim to be the real Gmail.
Mm-hmm.
Normally, you would get an error saying, hey, that's not the real Gmail. But because they managed to get this certificate, they could claim to be the real Gmail.
I see. Of course, yeah. Yeah, especially since everything has to route out through their endpoints at some point to get to Google's servers.
Exactly. And that's always been a concern with certificate authorities is, like with the big American ones, they might issue a certificate like this to the American government. So the American government could wiretap your Gmail, even if you're using SSL or whatever.
Mm-hmm. I guess this is always sort of the trust that we as end users put in our ISPs in a sense, right? Because you just have to trust your ISP wouldn't do something like this.
The idea of SSL is you don't have to trust your ISP. you trust the certificate authority to verify
right.
the site.
Unless,
And in this case, they're doing a horrible job.
Yep.
Or
Unless,
worse, they gave a certificate to someone who shouldn't have had it.
You've got a link to...
Basically, they were attacked, and then they had an external security audit done, and that audit falsely determined that all the invalid certificates had been revoked.
Oh, no kidding.
Apparently, nobody bothered to check on the one for star.google.com, which is a wild card for anything at Google.
So not a very thorough audit.
Box, Gmail, etc. Apparently. So it raises some serious questions about what seems to be a cover-up, right? Like, if they knew they got attacked on July 19th, why was this whole vulnerability thing not discovered until, a couple of days ago?
A cover-up on...
August.
A cover-up on whose part?
DigiNotar. They didn't announce that they've been compromised and that, people should double-check all their certificates and so on.
Right.
Just a month later, somebody happened to be using Chrome in Iran. And Chrome has a new security feature that they built into it where Google says the only certificate authorities that will ever issue a certificate for Gmail are this one and this one. If the certificate's from anybody else, it is invalid.
Interesting. So this is built into Chrome since June 2011.
Yes.
So this is not a super... probably it's not out there for everybody yet. It's probably not well established, but it's got to be filtering out there through the update systems.
Right. And so specifically, this is Google's response to the last time this happened to them with the Komodo SSL certificate compromise.
Oh, okay.
Right, that we talked about on a previous episode. And so Google has started building this system where they will allow companies to publish a list of who their certificate authority is, and so that if any other certificate authority issues one falsely, this is a system that should never have to be in place because the certificate authority should be doing their job, but not. And so Google's added this extra layer of protection.
Good on them.
And the other thing is, for the sites that have this extra feature, they prevent self-signed certificates from working at all. Normally, if you go to a site that has an invalid certificate or a self-signed certificate, you get this giant scary warning, right?
Sure, yeah.
But some users just click through it anyway. I remember when I was a student at college, the college's internal learning management system had a bad certificate, just a self-issued one. And they basically conditioned students to just accept it and continue on, right? And that's a bad thing, a bad habit to be in.
Right.
So anyway,
you just want to stay vigilant with those.
If you have Chrome, it will actually not allow you to accept an invalid certificate for Gmail.
Oh, okay, good.
Prevent you from making the connection, no matter
I think
what.
Microsoft is working on a system like this for Internet Explorer as well. I don't remember what it was called exactly, but I remember hearing something. I don't know if I think it's actually built into IE9 if I recall. So I would assume Firefox and Apple will probably work on similar features because that seems like a pretty low impact thing for them to implement, which can dramatically improve your level of trust. The only problem is they have to know where they can implement those things, right? Google's kind of in the position of owning the end destination and the web browser. Right. So they can kind of put these rules in for things that apply to Google.com that maybe the other browsers makers can't.
Right, and so eventually there'd have to be some standardized system for listing what valid certificate authorities and so on. But really the solution is to not have trusted authorities issuing invalid certificates.
Yes, well.
So Mozilla and the other browser manufacturers have taken more direct action this time than they did last time. They've completely revoked DigiNotar's trust from the browser. So any certificate signed by DigiNotar is now shown as invalid by all the browsers.
And they're doing this through an update to Firefox and through Thunderbird and to SeaMonkey.
And
right?
There's one for IE, or for actually I think it's a Windows update that affects everything that uses the Windows SSL layer. And then there's one for Chrome and so on. So all the browsers are covered. Good.
So everybody's responding fairly quickly.
Right. So if you remember with the Komodo compromise, the browsers issued an update that blacklisted the 3 or 4 certificates that were a problem.
Mm-hmm.
With this one, they've completely revoked that certificate authority's ability to issue certificates.
So that's a pretty... They're out of business. They're done.
Unless they get re-added. Yeah. So that I wonder, does that mean, is it just the browser companies sending a strong signal to all CAs that if you don't, step up your game and keep things secure, we'll put you out of business? Or is it that there's evidence that DigiNotar was in fact cooperating with the Iranian government and did this on purpose?
And so they're just making it, so they're just taking care of it. And
if the Iranian government offered them enough money, they probably would have done it, right?
And they found out, so they're saying,
who outside of Iran is going to notice or care? Right? But
oh, that's interesting. Yeah, because we do know that they use those to, You're just kind of connecting the dots there, but that does make sense.
Right. Well, it's specifically, this is the second time it's happened.
Right.
And both times it was Iran.
Right.
But specifically, to do the man-in-the-middle attack, you would have to be between the end user and Google. Now, that's possible if someone had this Google certificate, if they had the private key for it as well, or if they could, get somebody to issue them a valid certificate for Google, you could sit at a Wi-Fi hotspot and get everybody on their Gmail.
Yeah.
Including, most people's phones can try to log into their Gmail and stuff.
Mm-hmm. That's what I think about, is all these portable devices that auto-connect to Wi-Fi, that are constantly logging in, checking your email, pulling your IMAP down.
And especially some of those might not even have the invalid certificate warning.
Well, how does that work, right? How does that work? Because you can update the browsers, but what about all these devices?
Well, Firefox for mobile was updated.
Well, okay, but there's a lot of different mobile web browsers out there, and there's SSL certificates just in email clients, and there's in IM clients.
Like my Windows Phone obviously has the proper pop-up message when a certificate's not properly signed.
Sure.
But the Windows Update won't have updated the certificate list on that. So this false Gmail certificate will probably still work on my phone.
That's what I'm thinking, right?
Yeah.
Why wouldn't it work on my Android device?
Yep. And I wonder about iPhones. I didn't see anything about an update for iPhones.
Disappointed. Chris is disappointed here, Alan. I don't like this at all. This is a fundamental flaw in the way SSL works. If you can't trust these original guys, in this case.
Well, and the other problem is if they're because they didn't do just Gmail, right? They issued like 200 fake certificates, and some of those were for things like Mozilla.org. If you were able to get a fake certificate for Mozilla, then you could block the users from getting the new version of Firefox to get the update. Right?
Wow.
If you're the ISP, you can just say you can't go to the Mozilla website. We'll redirect you to a fake one or whatever, so that you can't get the new version of Firefox, so that
you don't
it doesn't disable the certificate.
You see malware makers do that on Windows all the time.
Exactly.
When I'm constantly cleaning machines, they always try to block Windows Update. They try to block the AV. They try to overtake your Google searches. They monitor what you search for, and they redirect constantly.
Right. And so with this one, they could, if they had a fake Mozilla certificate, they could pretend to be Mozilla, and when Firefox checked for an update, they could issue a fake update that actually injects spyware into Firefox, turning your own browser against you.
Well, that's kind of scary.
Yes.
I don't like that idea.
But that was the other thing about that Chrome thing we were talking about, the extra security.
Yeah.
It forces SSL no matter what if you have that enabled as well. So, like, if you are the Iranian government and you are, or the ISP, and you're hijacking Google or Mozilla.org, if you just don't have any SSL at all, people would never be able to tell that it wasn't the real Mozilla. Right? So that's why this Google extension that they're building it's also forcing SSL for the websites that have saying, we only accept certificates from these issuers, also saying that our site is always SSL all the time.
Right.
So that a fake version can't be out there with just something like SSL strip, which just, as you're doing your man-in-the-middle attack, anytime it tries to redirect you to SSL, you just prevent the SSL part from happening.
People need to patch. I mean, if you're a Google services user, you need to update your browser.
Well, mostly this was isolated to Iran, but yes, you should update.
Well, but if it's out there, right? I mean, why does it only work in Iran?
Nobody else has the private key for the certificate to use the certificate.
Okay, so as long as that doesn't get out there.
Right. But specific, like the person to do this attack, they would have to be in the middle, right? They would have to be between you and Google.
But again,
so if you're on your home line, then you're okay. But if you're on Wi-Fi,
but the real threat here, I think, the reason I think of it is because as an IT person, For one, what was that Firesheep? It was called that Firefox plugin that would monitor people's web traffic and automatically get their login credentials for Facebook and whatnot. And it was just you plugged it right into Firefox. I ran that on the network that I was administrating just to see how insecure the network was, and it was incredible. The kind of power that a person at your place of business has. I mean, they could easily do something like that at your corporate firewall or something like that.
Yep.
And that's why it just seems like if that private key did get out there, you just have to be prepared.
In a company, there's an even worse issue. Because they control your computer, they could install their own certificate authority and then issue fake certificates for Google. But that would only work inside the company.
Yeah, but that's true.
But, they could do that and, monitor everything you do back and forth to your Gmail or any other site they decide to attack.
Yeah, if your company... if you have to have like a certificate to use a VPN or something like that, then they're already doing things like that. So they've already mastered that. So they could also master that. So I guess always watch for that. But I got to say, just update your browser. Do it. Patch it.
This idea with Chrome, where they would say our certificate only ever comes from here, would solve that.
Exactly. That's why I kind of like it. I mean, in one sense, it's a lot of power.
If it's not built into the browser, if it's an index it goes to check, what stops them from doing the man-in-the-middle attack on that index?
And you wouldn't want to hard set it in the browser because you might want to be able to change it at some point.
You can do that for every site, right?
Right.
If you want to be able to expand it beyond just Google. Actually,
you know what? I think from what I remember reading about how Chrome does this, right now it is a hard list built into Chrome.
Yes, because it only does like 5 sites.
Yeah.
If they wanted to expand this, like they talked about, it would have to be some kind of index.
And this was where the difference in the implementation lied, is Microsoft was coming up with a system that was remote and that was a database and that...
Right, but how do you prevent that database from being susceptible to the same attack?
I don't know.
I guess you could hard code the connection to the database.
Yeah, and then you can only update that through software updates, maybe. Huh. It still seems like there's more room in there for something to get taken advantage of, whereas Google's approach is hard set. So unless you modify the code of the browser, which at that point, if you're giving somebody a modified executable, then that's
everything's out the window.
Yeah, you're done already. Well, so what else? Anything else for the story? I know you have a bunch of links.
Lots of links. We have links to Mozilla's take on it, Chromium's security blog,
including also a paste bin of the fraudulent certificate, which is kind of neat.
If you're interested, and also a press release from the parent company of DigiNotar. It's like their side of the story.
Oh, okay, good.
You kind of see through a lot of the things they specifically didn't mention because it made them look bad and so on.
Well, there you go. And also a link to your write-up, right?
How little the parent company cares. They're like, yeah, we don't expect this to cost us very much money. We only made $100,000 off certificates so far this year, so we don't care.
Whatevs, no bigs. And also, is that a link to a blog post of your own there?
Yes. I wrote when the Komodo SSL certificate authority was breached, I wrote a blog containing even more detail than could possibly fit in an episode of TechSNAP.
Right, I remember.
So I linked to that again because if you want to understand what's important for all this stuff, it explains it in a little more detail than we can in a live show.
Yeah, it's good. That was a good post. All right, should we move on to the next story?
Yes.
Let's talk about a faster internet through the magic of DNS. At least that's what Google and OpenDNS are claiming. And of course, what I find interesting about this is really until this announcement, I kind of saw Google DNS as a direct competitor to OpenDNS. And I'm a big fan of OpenDNS. If you haven't seen it, go check it out. It's a great way to provide really high-level, like, malware filtering, porn filtering for corporations without having to do any heavy software. You can do it all at the DNS level, and it's really pretty brilliant. Now these two companies are coming together and saying we can make DNS faster. Is that what's going on here? Because I saw these headlines.
When people started using OpenDNS and Google DNS, it created a problem for the content distribution networks of the world, which is how all the big downloads and all that media gets distributed.
Okay.
And in order to act, because basically in some cases using Google DNS and OpenDNS ended up, your DNS was faster, but your actual internet connection was slower because of it. Because you were going to the node that was closest to Google, not closest to you.
Instead of like your ISP's server that could be.
Whereas if you use your ISP server is likely fairly proximal to you, whereas the Google one isn't necessarily.
Right. Not in all cases, though. Some ISPs, some of the big ISPs, don't.
And because Google's using Anycast, which we'll actually talk about a little bit later, you're going to the closest Google node, which are all over the place. But when the site you're going to sees the request come in, it sees it coming from Google in California.
Oh, so that's why you're saying it affects this content distribution nodes, because then they see it.
Because with, geo-IP, right?
Yeah.
Well, the geo-IP for one address is only ever one location, even if that address technically happens in more than one place. And so, so basically, if you're using Google DNS, all the websites always see you're at the DNS level. They always see you coming from California. So they route all your traffic to California. Now, if you happen to be in Germany, that's really going to suck.
Yeah. Yeah, if you're on the West Coast, like I am, it might not be too bad, but So they kind of when people started using these services, they kind of caused a big problem for people like yourself and for like iTunes and Netflix.
Yeah, iTunes was a lot of people were complaining that when they used Google DNS or OpenDNS, their iTunes downloads were a lot slower, and this approach called afasterinternet.com will solve that.
Now, what is it? What's the solution?
Right. So what they're proposing is an extension to the DNS protocol called eDNS for Extended DNS Client Subnet. So when the DNS server that you use, whether that's your ISP or Google, when you make the request to it, normally it forwards that request to the authoritative server, the server for whatever site you're going to, right? And so that server sees it coming from the DNS server, not you, directly. And so it uses that IP in its decision of where to send, which server is closest to you. So this extension, what it does is it sends the first 3 octets of your IP address, not the 4, so it's still anonymous, to the authoritative server. So when Google passes this request to, say, iTunes, it says, yeah, I'm Google, but this request is actually on behalf of this IP block or someone in this IP block.
Oh,
and
okay.
iTunes can then use that IP to decide which server to send back.
So you can use Google DNS or OpenDNS, and they're not forwarding on all of your IP information, so you're actually getting a little more anonymous.
Where you are.
Right.
Right.
So you're technically your privacy level is actually a little higher now.
Not quite, because
No?
Google didn't pass on anything before.
Oh, okay.
Right, but the whole subnet, that's 255 people, right? Like, it's anonymous enough.
Yeah.
And the site is going to get your IP address when you go there anyway.
Well, that's what I was thinking. Traditionally, they would have had the full address, or probably the full.
And iTunes is still going to get that. Just at DNS time, they only get the first 3 octets.
Right.
And so someone monitoring DNS, like your ISP or whatever, can't quite track it all back. So anyway, by passing along the first couple octets of your IP address, that means that the server on the other end can decide which results to send back to you, and that way more likely to send you to the closest server. Right? So like a lot of CDNs, including Scale Engine, use GeoIP technology at DNS time to decide which server to send you to.
Right.
So when you look up, when you go to Jupiter Broadcasting, all the images are loaded through the CDN. When you look up the IP address of the CDN, it looks at the IP address of who's asking, figures out where that is, and sends them to the closest server.
So they're getting the files from the location nearest them without having to go all the way to wherever our server's sitting.
Right. And the problem with that is, if you're using Google, until now, you would have gotten back the IP address of the Los Angeles server, because that's the closest one to where Google's IP address is.
Did you have to make changes to Scale Engine to support this?
Yeah, we're using a different DNS server instead of Bind now. We're using a GeoDNS server.
Ah, okay.
Which has, I'm guessing Bind will soon have support for this eDNS extension as well, though.
I notice also that according to the Google article that BitGravity, CDN Networks, DNS.com, and Edgecast have also deployed this.
And the companies that were sponsoring this, the development, were Google, OpenDNS, and Newstar, which is the owners of UltraDNS. That's the company that runs the .org top-level domain.
Okay. I'm a huge OpenDNS fan.
VeriSign, I think, was in there as well. The company that owns the .com and .net top-level domain.
Very cool. So what do you think? A good move, right?
Very good move. And Scale Engine is working on deploying this as well.
Yeah. I would think that I didn't even realize that was such an issue, but I would think as more and more people are deploying the Google DNS service, which I've read is doing quite well,
Yep.
this must have been a very frustrating thing for a lot of the content providers because it's kind of like, in a way, Google's screwing with their delivery to their customers.
Yeah, and it's more so they have to keep adding more capacity at their California node.
Well, that too,
that's
right?
where all the traffic's going, but that traffic isn't necessarily like they'd be better off delivering to people in Germany from their data center in Germany.
Yeah.
But because the request is coming through Google, they don't know that the user's in Germany.
Strengths in the IRC chat room is asking if this affects IPv6. This doesn't make any... this is a DNS level thing, right? So does it make any...
So most of these sites aren't using IPv6
right.
for
but
CDN.
If they do, they could still use this service.
Yeah. And yeah, it would work the same.
That's very cool.
Of course, in their extension, it's only got the 4 octets, so it would be weird to do it with IPv6, actually.
Yeah, okay, that's true, huh?
But I think IPv6, they're just going to do it a little different, and it'll be better anyway.
Any other thoughts here on this story?
No, just I was interested in this because after reading it, I actually went about implementing this, and we have a couple testing GeoDNS servers set up now, and we're going to start mixing them in with our regular GeoDNS servers and seeing what kind of a difference it makes.
Interesting. And any thoughts so far on GeoDNS compared to Bind?
It has some monitoring built in, very basic, but it will basically automatically remove IP addresses from our pool when it detects that they're not responding properly.
Oh, that's kind of nice. So you don't have stale records hanging around?
It'll add additional failover monitoring, which would be quite helpful.
Always a good thing. Should we move on to the next story?
Yes.
All right, so let's talk about this one. Is interesting. Might even slip its way into the Linux Action Show on Sunday, especially depending on what you tell me here. Because this is Alan, it's great. You're covering all the stories this week that I managed to read the headline and did not read anything else. I love it when that happens. I sit down and I get caught up on the really interesting security news. And of course, Linux, while we all love it, doesn't mean that sometimes it's not a target. And kernel.org was one such target that just happened recently. Now, if I recall correctly, Alan, somebody got like login credentials or something like that? What happened?
Yeah, so they managed to get into some regular user account somehow. Basically, they managed to steal someone's password, guess it, or something to that. Then, using some unknown means, they managed to escalate that to a root privilege.
I bet Linus had his FTP login password set to Linux Action Show, so somebody probably just guessed that. That's probably what happened.
Probably.
Yeah.
And then once they had root, the attackers actually replaced the SSH server with the Trojan version.
Oh,
and
very nice.
Through that, we're able to get the credentials of every other user when they went to log in.
Very nice. So they once again used one level of entrance to then escalate up to another level, replace something very valuable, which then gives them sustained access.
Yep. Specifically, I've actually seen this type of attack against servers before. And on my servers, the SSH daemon is CH flagged so that no one can replace it. It makes it a pain when it's time to upgrade, but it prevents this type of... It's also funny when people try to do this on my BSD boxes with a Linux version of OpenSSH, and I get to laugh at them.
Yeah.
It's like, thanks for bringing your Linux exploit over here, but it's not going to work.
It's not going to work, no. So they say they've already taken the boxes offline, and
there was a number of boxes.
But doesn't look like any code was compromised, right?
Because they use Git, they're saying that the way Git works is impossible to change an existing version of the code. They would have just applied a new patch or whatever.
Right.
And so that it'll be easier to... They won't have to do a line-by-line check to make sure nothing was changed.
What I really like about their approach is, and it sucks that, a well-known Linux site, especially one that, is the home of the Linux kernel got
but
hacked.
Specifically, the way they're handling it is proper.
Exactly, and that's what I really like about the way they're doing it. I'm reading through here, the communication is in depth, it's clear, it talks about their process, it talks about their rationale, it talks about what they know. I mean, this is a very good, clear...
anything.
Right, it's a very good... And that is even more important in open source, because one of the reasons a lot of IT guys will get into open source, for me, I know where Debian is going probably for the next 5 years by just watching the Debian mailing list, by watching the development process. Just like, Alan, you could say the same about FreeBSD, I'm sure, right? Yep. So what you end up with is you end up with this open process that you can then plan around. You can set your expectations. You can sort of build a platform on top of that. And when these sort of things happen, this level of communication and this level of details plays into that whole thing. It gives you a complete picture, so you're able to then brief the people that you report to, because you've got to tell the people, yeah, hey, you know that those Linux systems I implemented, well, they have this issue. In a lot of cases, they require that you report that, and these kinds of things where you give them the full detail, they help everybody involved. And then you can also learn from them just by watching the process.
Yeah, and, it's just important to not try to cover these kind of things up. Mm-hmm. It's to admit that you had this problem and that you are dealing with it, rather than just trying to sweep it under the rug, which is what DigiNotar seemed to try to do. Right. And then that backfired and exploded in their face, and now no browser will trust them.
So,
but yes, there's some serious implications to this. If someone did manage to change the code on kernel.org and everybody updated their kernel from it, then you could have all these kernels running around with Trojan code in them. Now, they're fairly sure that didn't happen, but they're still double checking.
It looks like, though, they ended up with 448 different user account credentials.
Right. There are 448 people who have access to kernel.org machines, and all of those people are having their passwords replaced and all of their SSH keys.
Good.
Because if you left your private key on that machine, it's obviously compromised now.
Yeah.
And that might have actually explained how they managed to compromise so many machines.
How did they find it?
They actually said that they were seeing this weird error message about /dev/mem, and it was some kernel warning or something about a specific program that they didn't have installed. And so then, when they kept seeing that, they decided to investigate. And specifically, they've said if any developers, specifically these 448 people who have accounts, because they're the people that are actually contributing, see this error, they should definitely check their system and see if maybe they're compromised as well.
There's an additional article you can read, and in there they mention, we'll include a link in the show notes, they mentioned that they logged all of the user interactions, and they have the exploit code. And I like the line here, we've retained this code for now. So they're going to go ahead and look at the Trojan code and open source that
what
sucker.
else it was doing.
Yeah, I love that. It's a great idea. It's
specifically, we saw with the DigiNotar one, right? They assumed that they had fixed all certificates and that nothing was wrong,
right,
and that they were all fine. Or Sony, when they got hacked,
right,
they hired this external company to figure out why, but they never looked at making sure everything else didn't get hacked.
But if you look at the actual code, you know what it does,
right?
And what a great group to look at the code, right?
Right, and also, like you saw when they said, we don't believe that any of the kernel code was modified, but we're going to check very thoroughly.
Good.
We're not just going to, it doesn't look like it, so we'll assume it wasn't.
Right. And I think with that, we'll go on to the TechSNAP feedback. And this week, we wrap up the question that we have spread out over a couple of episodes now. Dreams Void wrote in a while ago and said, how do I accomplish something? And Alan said, well, that is a big question, and so I'm going to give you a few different answers. And essentially, Dreams Void wants to build the most amazing website that never goes down. He wants to be able to accommodate and repair from an outage and sort of seem like he's never down, deliver almost 100% uptime. Alan, you've had a couple of different takes on how to do that. This week, though, this is the one I'm probably the most excited about, and it's also one you're kind of looking into for your own purposes, right?
Yep.
All right, so what's it called?
How I have all this information, I've done all the research on this one.
What do we got here? What are we working with today?
Right, so this is, again, the same question we've been working on for a couple of weeks, is I have a server set up, and how do I make it so that a second server takes over when the first one goes down?
Yeah, so that way you always look like you're up.
Yeah. So this week's solution is called Anycast, which you heard me mention a little bit about earlier. And it's by far the most complicated and resource intensive, but it's also the most scalable. It allows you to scale to however many separate servers you might have.
Anycast, huh? It sounds like something you'd use for streaming video or something.
Kind of. So a standard connection on the internet is what's called unicast, right? It's from one point to one other point.
Sure.
Right? It typically from a client to a server, but that's not the important part. Right? There are also broadcasts, which is from one point to all other points.
Right.
Now, that's actually contained, right? On a LAN, you would do a broadcast, and it would get everybody on your LAN, but it wouldn't go through any routers.
It wouldn't be routed, sure.
Routers create a domain where broadcasts don't go through them.
Right.
Multicast is a way for a group of people to subscribe to receive a packet. So you send it once, and everybody that's subscribed gets a copy. Routers use that a lot for their routing table updates.
Mm-hmm.
But again, that doesn't normally go through a router. And you can specifically configure a router to pass it for a big LAN or something, but it doesn't work on the internet.
Okay. So this is where Anycast comes in to sort of provide a similar solution?
Anycast is a little different. So what it does is when you send a packet, instead of going to that one location, that one IP address exists in more than one location.
Oh, we've blown my mind there. Tell me about that.
Yeah. So basically, a number of different servers all have that same IP address. And the routers on the internet know which one of those locations is closest to them. So when you go to connect, your ISP says, hey, this one's the closest to us, so I'm going to send the packet there.
Oh.
And now closest, it considers it in the terms of the network, not geography. So it's looking at the fewest number of hops or the least expensive hops. Because most ISPs will have connections from a number of providers, and they'll classify them saying, this one costs this much per gigabyte and this one's cheaper. So use the cheaper one when you can. But, if it's busy, use the other one and so on.
Oh, I see. Okay.
A lot of complicated rules, both business rules and also, congestion and performance rules.
So it helps not just from a redundancy standpoint, but also from a performance standpoint.
Yeah. So the way Anycast works is your BGP-enabled routers will broadcast out to all the routers that are one hop away, saying, I have this network. So if you need to get to this network, send it to me. Right? And then each of those routers will broadcast that on up the chain until it gets all the way out to the internet, right?
Mm.
And then so each router on the internet knows the closest route to get to every other point on the internet.
This must ride on a lot of different protocols. This isn't just one single system. Like this seems like it would rely on something like BGP. It would rely on.
It's all BGP.
Okay. And BGP is sort of like this communications protocol between routers that lets them sort of communicate and let you inform each other where they're at.
Yeah, to basically have a giant table that says to get here, go this way, and to get here, go this way.
Okay.
And that way your traffic is always diverted to the nearest location.
Right.
If one of those locations goes down, then the router at that location will stop sending its update. And after a couple of minutes of no update from the downed router, the next nearest router will say, hey, that's not there anymore. I have to find the next closest place. And then, the whole internet converges and adapts and goes to somewhere else now.
Uh-huh. So that means you don't have to have... That means... Are you telling me, Alan, that there's not monkeys sitting in closets that are pulling out connections and then plugging them in over here to accommodate for outages? You're crushing everything I was to understand about the internet, sir.
So... based on that, if you want to do only failover, right, with this system, traffic is always going to go to the closest server.
Right.
So your backup server is going to be getting traffic from everybody that's closer to the backup than they are to the regular server.
Right, okay.
If you don't want to distribute your traffic geographically like that, you just want to have failover, right? So the backup machine should be completely idle unless the primary is down. Because depending on your setup, you might want to do it that way for your database or whatever.
Mm-hmm.
Then what you do is the router at the backup location will put its own, on the routes it sends out, it will prefix its own autonomous system number a bunch of times. So basically it'll add itself as a hop in the route, like 3 or 4 or 5 times, so that when the routers are measuring how many hops it is to get to the backup location, it'll be longer than the number of hops to get to the primary location, even if the primary is further away.
So it's sort of artificially...
Yes.
You
artificially make it look like a worse route.
Right.
So it only gets used if the primary isn't there.
That makes so much sense. I've wondered how they've done that.
Yeah.
Ah. Okay, so that would be because really, in the scenario where you're talking about, it's sort of load balancing traffic around, that other box doesn't become a backup. That's just as much in production as any other system. But where you use the thing where it appends its own address a bunch of times, then you're sort of forcing traffic to go to one spot, and now it does become just an idle system. Because that other one could still go down, even with that long chain of addresses on there, the other route will still work if that other one isn't available at all.
Exactly.
That's cool. I like that.
But there are some caveats with this solution, with Anycast. Because TCP packets were never meant to randomly go to a different location. So if you're connected, if if we say used Anycast for IRC to send you to the closest IRC server,
Sure.
that would actually be bad, because if the route ever changed, you would get randomly directed to a different IRC server where your connection isn't actually open, and you would just randomly get disconnected.
Right. So you have to, once you connect to one host, you have to have a persistent connection to that same host.
Right, and with Anycast that doesn't happen. The route changes. The route could change at any time.
Gotcha.
And if it happens in the middle of the session, it gets disconnected. So this makes it unsuitable for any long-lived connections,
Gotcha.
like IRC or anything like that. But if it's a short-lived connection,
Like fetching an image
you're
file.
just fetching an image, it's not a big deal.
Okay.
But one solution around this, especially if you need that long-lived connection, because some websites do,
Or
right? If you're doing like a lot of, if you're doing say Google Docs, where you're going to have this AJAX going constantly, you don't want that to happen necessarily, right? And because the routes on the internet are constantly changing, routing around faults and around congestion and finding the optimal route, right?
Yeah.
So what you want to do is use Anycast for the DNS. And then in DNS, you give out a different IP, the local IP. Right? So the other limitation with Anycast is you can't connect out from an Anycast IP.
Oh,
right?
okay.
Because if you connect out from the Anycast IP...
The reply would be crazy.
The reply goes back to the server in Germany who's like, I didn't ask you for that. What are you doing?
Right. Yeah. It'd be haywire.
So if you're doing Anycast, each machine also has to have its own regular IP address.
Mm-hmm. Sure.
For connecting out on and everything.
Okay.
And for administration and so on.
Yeah.
So what the solution you can use for Anycast is you have Anycast do DNS, right? So the DNS request goes to the closest server. And on each of those DNS servers, instead of having the regular zone file, you have a special copy of the zone file that says the IP address of the web server is the local IP of the web server in the same location, right? So my DNS server in Germany says the IP address of the web server is the German IP address, and the one in Los Angeles says it's the Los Angeles IP address.
Well, so this seems like you could host this as a service. You could provide this hosted Anycast DNS as something people could subscribe to have their own redundancy like this without having to build it themselves.
If they had servers in all the locations already.
Right.
But yes.
Right. You should do that.
So because
I'm just saying, Al. I would pay for that. You should do that. You should.
Well, Scale Engine already does.
Right. If you use Scale Engine hosting,
not
sure.
using Anycast yet, but we're going to be.
Right. If somebody was already using the hosting, yeah. Cool. That's really cool.
And so basically and then you send out the IP of that local server, and then it just becomes a regular unicast connection. Because especially with video streaming, right? That's a long-lived connection, so you wouldn't want it to constantly be interrupting the video stream.
Right. Yep. Yeah. What would it take? Let's say I wanted to build my own server, and I wanted to get a video stream or something like that, and I wanted to use Anycast. Is this something that is like implementable by a regular man, or is this something that's now been like reserved for only the big guys?
Depends. You have to find an ISP that's willing to help you.
Okay.
But the other thing is this solution suffers from the same problem as the Google DNS story that we talked about. Right? If you use an Anycast for the DNS,
right,
you're getting whichever location is the least number of hops from Google. Now, if Google's using Anycast too, you'll end up getting the least number of hops from the user, the DNS, the Google server closest to the user, so it won't be as bad. Right? Because the connection will come over the link that's closest to the Google server that was closest to the user.
Right.
But that isn't necessarily your server that's closest to the user.
Excuse me, I'm coughing.
Right. So again, this extended DNS thing may actually help Anycast as well.
What a nice little marriage made in DNS heaven right there.
Right.
Little DNS love story.
So to actually implement this, there's a number of obstacles you have to overcome. The first is because of the size of the routing table for the internet, no ISPs are willing to accept a route that is smaller than a /24, which is like 255 IP addresses.
So there's barrier one. You got to have a /24 under your belt.
So you have to have an entire address block to yourself.
Oh, let me just, I got that set over here. Okay, I got that. That's set aside. What else do I need?
Then what you also need is you would need regular IPs at each of the... Well, first of all, you need more than one location or more than one internet connection, right?
Right.
It can be two separate internet connections at the same location.
Okay, so my house and my mom's house.
Yeah.
Okay.
And then you'd need that shared block of IPs to do that you would use at both places, plus regular IPs separately at each place. And then to broadcast routes out to the internet, you would have to have permission from your ISP would have to be willing to accept routes from you
and propagate that into their routers and whatnot. Yeah.
But to do that, you also need an autonomous system number, and there aren't that many of those. They don't just give those out easily. So to do that, you have to be a largish ISP, or you have to have an ISP that's willing to allow you to announce the route using their AS number.
How common and likely do you think that would be?
It depends. From a dedicated server ISP, it's really hard to find. Okay. I've been trying.
Okay. So,
but there are a couple places that will. Like Pier 1, because we're a co-location customer, they will do that. But if we were just a dedicated server customer, they wouldn't.
Okay.
So they won't do it for us in Europe like we were hoping.
So this is a real challenge.
Yeah. And if you're dealing with more than one ISP, if you don't own the IP block, but that /24 is from your ISP, then to let the other ISP use it for Anycast, you end up needing all these letters of authorization and stuff. So it gets really complicated. But if you're going to have multiple data centers all over the world, it is basically the solution you kind of need.
Yeah, and it seems like if you want to get a worldwide audience, the crazy amount of impact that your site speed has on your viewers and visitors' acceptance of your site is so massively important that it seems like people go to these crazy ends to invent these systems, so that way when you out there go to jupiterbroadcasting.com in New York, it's an image that's on the East Coast, but when somebody in California does it, it's an image on the West Coast. Why would we go to all that work? Because it's fundamentally important to the end user experience.
Well, Amazon has found that every 100 milliseconds longer the page takes to load, it drops their sales by 20%.
And Google has found the same thing, that with every increase, the less and less likely people are to do searches. And I want somebody on a whim of a thought to go to Jupiter Broadcasting and click play and watch a video. I mean, heck, that's why we went to HTML5. We lost all ad revenue in our videos. It cost us a ton of money to do that, but the whole hope is that it's just a little less. When you hit that play button, it starts immediately.
Less time before the video starts.
And that is extreme, and that's so important that we're foregoing the ad revenue. So there's systems that people are building. When you're building your site up and you want something that people are going to use, and especially if it's multimedia rich, these kind of things are what you got to look into.
And again, that's the goal behind Google and fasterInternet.com. Is the reason behind OpenDNS and Google DNS is a lot of ISPs have really crap DNS servers.
Yeah.
Right? They have these machines they built in the 90s, and they're like, it's a DNS server. It doesn't need that much.
Yeah.
And it's just, they're not doing that well. And
I laugh because I have probably been the guy that's been said before, it's just a DNS server. You can just throw it on any box. It doesn't matter.
And that's mostly true, but if you're Comcast, you need some beefy DNS.
Yeah, exactly.
Or I found the reason why I started using my own servers for recursive DNS instead of using my ISP was I was finding that when I had Bell, that they would be down sometimes.
That's happening too, yeah.
My internet's up, but I can't get anywhere because I can't resolve anything.
Because of that, and because I just found it to be faster, I set up my own local DNS server in my house. Not only is it nice to always be able to address all my systems by name always, but it's also Steve Gibson, that's who it is, over at grc.com has like a DNS benchmark tool, I think, and I ran it, and my local DNS server is significantly faster than any remote DNS server, and that makes sense, right? Yep. It's a LAN, it's a gigabit connection, it's boom, boom.
In the end, that might actually be slower because unlike Google, your local DNS server isn't going to have cached the sites you haven't been to yet.
Right.
Whereas Google, unless you're going to some really esoteric site, Google probably already has it cached.
So I have it forward to OpenDNS, and then over time, it caches and it builds it up. So now, after 2 years of running it, it's pretty great. Yeah. And it's super easy to set up.
It's like, if you look at something and then Angela looks at it, it's already there.
Yep. And so, I mean, it's a little too much IT for the homes in some ways, but it's so convenient in other ways.
Yeah, exactly.
So, any other thoughts on this feedback question?
No, I think one page of show notes is enough.
It's tons of great stuff in the show notes on this one. So, all right, Alan, you know what that means? It's time to jump into the TechSNAP Roundup. Okay, sir, it is time for the roundup. Now, the roundup, for those of you who are new to TechSNAP, is generally the links that were submitted to the TechSNAP subreddit page at links.techsnap.tv. Thank you, everyone that does that. And generally, they just didn't make it into the show as a full news story, either because of the research needed, but that we thought they were interesting enough that if
there's just not enough time in a show.
Yeah, seriously, if we had more time, we could do two tech snaps a week, and we would still have content. So what we've done is we've done this roundup segment where you can go through and do some additional reading on your own if you find these things interesting. We try to whet your appetite, but you can find all the links in the show notes over at jupiterbroadcasting.com. Just look for episode 21. All right, Alan, do you want to start with our first roundup story?
Yes. The Chinese government has pulled down all their videos about cyber warfare and denies everything.
So this was a funny one, right? Because they were like showing like there was like some sort of demo video running of like this great hacking software.
Yes, they're and how they're training all these people to be cyber warriors, and now they're like, that wasn't authorized. Pull it down.
Yeah, and I guess in the
none of that happened. None of that's real.
In the still of the video, there was like an American school institution in there that you could just click on and hit attack, and it would just launch these series of attacks against a university. And it's like, oh my God, guys, come on. So, okay, I'll take the next story in the roundup. Now, Alan, I didn't even catch this one, but it's a reset glitch that is affecting the Xbox 360 controller, and you can hack the Xbox 360 through the controller. Is that right?
And most importantly, is it allows you to run unsigned code.
Yes.
So it's opening up the possibility of running Linux on your Xbox 360.
And you see, this has kind of been something that there was kind of an entry point into the 360 at one point. Microsoft corrected that, and then further corrected it with the new Xbox S model that came out like last year or something like that. So this is kind of the first breakthrough again for getting a possible doorway to get Linux on the Xbox. That they've sort of been working towards this, and so this is kind of a big moment. And it's all written up on this wiki page here. But I gotta say, and the chat room's agreeing with me, Xbox 360 could make a badass little Linux box, and possibly a Bitcoin mining rig. But I'll save that for the Bitcoin Blaster segment. But I'm just saying that could be pretty cool. All right, Alan. The next story on the roundup is yours. It's an anonymous story.
Yes. Anonymous is taking credit for a denial of service attack against WikiLeaks. But this isn't just low-orbit ion cannon and trying to overflow with packets.
Okay.
They're actually doing the definition of denial of service where they're doing a resource exhaustion attack. They found an SQL injection vulnerability in the site that's minor. Basically, they weren't able to delete the data or insert new data or anything like that, but they're able to make the SQL server do a bunch of work.
Yeah.
And by just flooding it with these requests, they've slowed the SQL server down so much that the site can't load quickly.
I guess they used a combo like JavaScript vulnerability, which then started injecting data into the SQL server and just made it go crazy.
Yeah. And basically make it do a bunch of math or something.
Now, the next story is also an anonymous story, and it's about...
Yeah, and this is the same thing, basically. When they built this tool called RefRef or something like that, they decided to test it out on a couple sites before launching the attack on WikiLeaks.
They tested it on their buddy's Pastebin, who then they tweeted it and said, please don't test your software on us, guys. We hate graphs like this. And then they linked an image to the graph of like what their CPU or their SQL database is going nuts.
Yeah. So Pastebin.com is where Anonymous tends to dump all their information.
That's why I was surprised to see them go after their boys. They use those guys.
Anonymous uses Pastebin.com as a host, and they were attacking them.
That's dirty play, guys. Dirty play.
Yeah.
All right.
Take out your own stuff, why don't you?
Now, the next story on the news docket, or on the roundup, boy, that's hard to say. That's hard for my brain. This one is funny. I had a client ask me this question late last week, and it went something like this. Chris, we have a lot of remote desktop connections open on this network. They actually have like 15 ports, like different remote desktop hosts that you can get to. And is there any possible way for malware to spread through the remote desktop protocol? And I thought, well, not anything that I know of, but this roundup story has got me changing my mind on that. A worm spreads through Windows Remote Desktop. At least this is according to F-Secure, who says that the RDP server, which listens on port 3389, it will scan out there, look for listening through 3389, and then attempt to log in an administrator. And it uses a list of common passwords. So if you don't have a good administrator password, it can remotely log in to your system, and then, of course...
And then they can install whatever they want.
Yeah, they've got admin access, so...
Yep. Now, the Trojan's not very sophisticated. It doesn't check any ports other than 3389. And I know a lot of people that have this set up on the router have more than one port open for RDP because they have more than one computer. right? So they have a
Yes.
different port for each computer.
Yes.
And so only the one on 3289 would be vulnerable. But
Right.
if you're going to enable RDP, you should definitely have a strong administrator password.
Oh my goodness. Yeah, unquestionably. So did you see this roundup story? Actually, this almost made it into even as a news item, but again, time did not permit. But there's a story out of MSNBC.com, again, thanks to our TechSNAP subreddit, how cybercrime gangs stole $13 million in a day. And it's a story about how they compromise usernames and passwords through a database, get credit cards, and then start charging these accounts that they got from the leak of this credit card database. Yep. And they ran up a $13 million charge in a single day. And it's like this group of people that do this. Fascinating read to see about how like these people can now get together in these unofficial gangs and go out there and rob people electronically.
Yep. There was a similar one.
I got to get in on that.
Yeah. There was a similar one where they exploited a flaw in a banking system to do it with prepaid ATM cards. Basically, because banks settle transactions once a day at night.
Yeah.
In a batch.
Yeah.
Basically, if they cloned the cards and used them at different bank machines at the same time, they could withdraw the money multiple times.
Yeah, it's like a digital float. You'd be kind of yeah.
Because it didn't settle the transaction until that night.
Right. So they wouldn't catch it until they went to settle.
As long as basically they're doing it in a bunch of different countries. In countries that have older style banking setups, and basically they're able to withdraw the same block of money multiple times. It's actually one of the things Bitcoin's meant to prevent was this idea of double spend, right?
Yeah, because the network has to verify each block, and it goes through, and
you can't go back and change a transaction.
Let's move on to the next roundup story, Alan, because this one's kind of a disappointment. It comes out of Pakistan and about them banning encryption software. Do you have any thoughts on this?
Yeah, well, we've talked about this as a bigger story before. But yeah, so they've basically actually enacted it now.
Yeah.
So all forms of encryption are illegal in Pakistan, and they're also forcing ISPs to filter and block any encrypted VPN traffic.
Sigh. Yeah.
So if your traffic isn't clear text, it gets blocked.
So the last story that we'll throw up in the roundup, throw up for the roundup is it came out of WikiLeaks also. It's not really necessarily a bad thing, I don't know, but it just kind of documents how Oracle and the U.S. pressured the EU to approve the merger of Sun and Oracle. And these WikiLeaks reveal cables where Oracle essentially was able to co-opt the U.S. government to go over there and lobby on their behalf to the EU, who's sort of historically monopoly worried. The EU has gone after.
I think they were also worried about MySQL being under control of the company that does the Oracle database. Right,
because Oracle would then own the complete top end and the complete low end, and really that is essentially an enterprise monopoly for the database side. But what's interesting about this story is just how these tech companies are stepping up and utilizing both the politicians and their governments to pressure other governments. And if you're interested in that, there's a link in the roundup.
This is what happens when we let business people get involved in tech.
Yeah, I agree, right? I agree.
If MySQL had stayed a separate open source company, they would have never got involved with the government.
Yeah, you're right about that. You're right about that, Alan. Should we move on to the Bitcoin Blaster, sir? All right. Just a few links in the Bitcoin Blaster segment. We like to wrap up TechSNAP with a little chat about Bitcoin because it's something that both Alan and I followed. And Alan, what episode was it? Episode 9 or 10 that we did on Bitcoin?
9. Yep.
If you're a Bitcoin enthusiast, I'm really proud of that episode. I thought that was a really good episode on Bitcoin we did. You can go check out episode 9. But let's start off the Bitcoin Blaster with a little news about the difficulty level. It's gone down, and it actually looks like it's trending to go down again as well.
Yeah, it trended down about 1.5%, and it so far, based on the rate, it's going to stay about the same. Maybe drop by another 2,000 points, which is nothing considering it's at 1.77 million.
Also, as a corresponding story with the Bitcoin difficulty dropping is an article put out by somebody who frequents the Bitcoin trading IRC room. His name is Brock, and he wrote up a really great blog post about the relationship between the Bitcoin price and the difficulty level of Bitcoin. Because one of the common things you'll see on Reddit and the Bitcoin talk forum is back when the difficulty was going up, is the difficulty rate is going to increase. So everybody expect the prices are going to go up, and then when the difficulty rate goes down, there's a reason why the prices go down. There's a whole...
But the difficulty went down less than 2%, and the price went down like 20%.
Right. Well, there's a very good reason for it, and he kind of goes through it in his blog write-up. So I thought I'd include it in there if you've noticed that trend as well. It's funny because I had always, whenever people were saying, oh, Bitcoin price is going to go up tomorrow because the difficulty rate increases, I always thought, now, why would they think that? And if you think about it, people that are buying Bitcoins are aware of where the difficulty price is at. And they know that in 5 days it's going to go up. So if 5 days or even 3 days ahead of time you're buying Bitcoins, you kind of factor that into your purchase. And so by the time the difficulty rate hits, that's already been calculated in the demand for Bitcoin. That's why there's never this big increase in the price, because the market's already accommodated for that. And there's other points that he makes in this blog post that I really enjoyed the read, and it's not that long, so I'll link to that in the show notes. Now, Alan, I debated whether we should include this last story, because I don't want to come on here and talk bad about any individual person. I don't like to do that. But it's probably the biggest story in the Bitcoin community this week. And I will include a link to this, and with the warning that I've found that the Bitcoin community on a whole could sometimes be a little paranoid and jump to conclusions. Yeah. That said, they're often not wrong.
Yeah.
So you got to take that into consideration.
Bitcoin does kind of appeal to people that are paranoid and security conscious. And,
yeah. But they're also pretty smart people.
Conspiratorial, but yes, they also tend to be fairly...
Bruce Wagner is a well-known Bitcoin community person. He's the host of, he's the one that he organized that recent Bitcoin conference, and he also has a Bitcoin podcast. And there has been some evidence, and the only reason I'm even talking about this is because some of the things they found do kind of link him to some shady practices and potentially to the mybitcoin.com site. The links between Bruce Wagner and the mybitcoin.com site are a little shady. But here's what they are, is essentially mybitcoin.com had an outage earlier in the week, right? Because, they're back up so people can reclaim their stolen Bitcoins. And the outage revealed some information about the host and the host service. It's Arvixe, Arvixe. It's kind of an obscure hosting service, right? It's also the same hosting service and WHOIS registration that is registered to the onlyoneTV.com site where Bruce Wagner's podcast is hosted. So that's a little suspicious. They also dug into some of his background and found that he ran, unfortunately, either by mistake or by neglect, some mortgage bailout. He ran a mortgage bailout company, basically, where he was trying to help people that were going to foreclosure of their home, and took on a lot of clients, and nobody ever was awarded any money or was helped. And so he was sued, and he ran up a bill of about $500,000 in terms of legal fees, and his business was shut down. He's reported to the Better Business Bureau. But what's interesting is that during these times, there was a user taking to the forums defending his company, and really a singular voice that was defending his company. And again, this is just a loose connection, but the username of the person who was defending his company was Todd Williams. Now, the name of the mybitcoin.com guy is Tom Williams. So that's a little interesting. People have tracked this.
Preference when he comes up with aliases.
That actually, from a psychological thing, that's not uncommon, where people will have aliases that are very similar, like that Tom, Todd, Bill, Bob, those kind of things.
So that they can remember them.
Yeah. The company's name that he was involved in before was called Bold Funding, and it has a shady background. It fits a lot of some of this stuff. I'll just include the links in the show notes if you want to read more on this. Because it is something to be aware of. It's something to take into consideration, but it's only circumstantial evidence.
Yes, the internet is full of scams, and so Bitcoin will be no different.
That's just it. It's ripe for scams.
The level of anonymity that it has, it may actually be even slightly worse.
I think so. It's its strength, and one of its things that people will exploit.
Yeah, like I laugh when I see these. What do they call them? Things that you put in a coin and then it spits out more coins or something.
Oh yeah.
It's called.
Yeah. They have a bunch of those.
Bitcoin randomizer. Mm-hmm. I remember when they used to have those for PayPal and a bunch of other sites too.
So the last point that Bruce Wagner has been a very strong proponent of mybitcoin.com through his podcast. He was a very vocal advocate of the site. So people are thinking, because he was in a position to sort of be this vocal advocate, recommending people use this service, if he did have these circumstantial ties to it, he would be in a position to make a profit. I mean, it's kind of a brilliant scheme. Like if we had a popular Bitcoin podcast and we were telling everybody to go store their Bitcoins here, it's kind of like this. It's kind of like the radio hosts out there who are radio hosts, but they're really just gold salesmen. And all of their programming he's doing is trying to get you to buy more gold, and everything else is just a pretext to sell gold. It's kind of a brilliant scheme in a way, and if that's what it is...
Funny, as you say that, I'm looking at BitcoinWatch.com, and it's Glenn Beck's face on an ad for gold.
I didn't say that. I didn't say anything.
I know.
But yeah, so a link for this story in the show notes. I'd like to hear your thoughts if you're a Bitcoin follower. Let us know what you think. If you think it's legit, if you think he's a scammer, or if you think people are just beating up on a guy who lost money in a MyBitcoin.com thing. I'd like to know your thoughts. But you know what isn't a scam, Alan?
What's that?
TechSNAP. And TechSNAP is live every Thursday at 1 p.m. Pacific over at jblive.tv. But of course, you can download the released version of this over at jupiterbroadcasting.com on Fridays. And we have it available in mobile formats, high definition, audio only, streaming on our website, whatever you might like, as well as links to everything we talk about and a copious amount of show notes that Alan has diligently put together for everyone to go enjoy. Yeah? Alan, is there anything else you want to cover before we wrap up?
I don't think so.
Okay, everyone.
Covered quite a bit.
Well, we should mention if you want to send us some feedback, you can do that to techsnap@jupiterbroadcasting.com. That's the email address, or just leave a comment wherever you watched this episode, because we always love hearing from you. And we're always soliciting more questions, because we could always do a Q&A episode. Yes. We like to collect those for a little bit, so feel free to send your questions in, and we'll read through them, and maybe in the very short future, we'll have a Q&A episode where we answer all kinds of questions. Yeah? Does that sound fun?
Yes.
All right, everyone. Well, thanks so much for tuning in to this week's episode of TechSNAP, and we'll see you right back here next week.